In this video, we will make a proof, the derivative of x to the n using limits. If n is a real number, then the derivative of the dx x to the n is equal to n times x to the n minus 1 for all x, where the powers of x to the n and x to the n minus 1 are defined. Now, let's see why the derivative of x to the n is n times x to the n minus 1 using the limit definition. This is not just a trick. This method is actually where all derivative rules come from. Here is the important point. Ideally, we do not want to just memorize derivative rules, but to actually progress in calculus, you will need to memorize many rules. The key is that you understand where these rules come from, their logic, their foundation. In this video, I'm showing you how our very first derivative rule is derived. So you see the reasoning behind it and build a strong base for all the derivatives that will follow. Now let's take f of x equals x to the n. Then f prime of x is equal to limit as h goes to 0 f of x plus h minus f of x over h. And since our function here is x to the n, this is equal to limit as h goes to 0 x plus h to the n, x plus h to the n minus f of x. F of x was x to the n over h. Now, we will use binomial theorem here. X plus h raised to the power of n is equal to sum from k equals 0 to n x to the binomial coefficient of n or k, times x to the n minus k times h to the power of k. So x plus h, then x plus h to the n is equal to now binomial coefficient of n, choose 0, times x to the n times h to the 0 plus binomial coefficient of n, choose 1 here, x to the n minus 1 times h to the power of 1 plus binomial coefficient of n, choose 2 here, and x to the power of n minus 2 times h to the power of 2 plus, and this goes on, binomial coefficient of n, choose n here, x to the power of n minus n, and this is equal to 0, times h to the power of n. Now, this means x plus h to the n is equal to n, right, like that, n of 0 times x to the n. H to the power of 0 is 1 here, so I will not write it. N of 1 times x to the n minus 1 times h to the power of 1, but I will not write this one here, and n of 2 times x to the n minus 2 times h square plus n of n times x, x to the 0, and I will not write it, h to the power of n. You see, here we have an h here, where we have h square and so on. But we do not have h here. And actually n of 0 is equal to 1. This is equal to 1. And now I will take this part to the left. So the equation becomes like this. X plus h to the n minus n of 0 is 1, so x to the n goes to the left, x to the n equals n by n of 1, x to the n minus 1 times h plus n of 2 x to the n minus 2 times h square plus blah blah n of n times h to n. What was our limit? Our limit was that. So we have on the left x plus h to the n minus x to the n. So we will divide both sides by h. Dividing both sides by h. And we will take limit now. Limit as h goes to 0, x plus h to the power of n minus x to the n over h equals to limit as h goes to 0. Look at the right side. You see this h will go. N of 1 times x to the n minus 1 plus n of 2 times x to the n minus 2 times h plus, and the other term will be n of 3 times x to the n minus 3 times h square, and all the other terms will have h square, h cube, etc. N of n, the last term is that n of n times h to the power of n minus 1. Let's take this part here. You see that we want to find this part, and you see that this is also equal to that, and h goes to 0 here. When we take limit, h goes to 0. So because we have h here, this part will go to 0. Because we have h square here, this part will go to 0, and all the other terms goes to 0. So on the right hand side we have limit as h goes to 0, n of 1 times x to the n minus 1. So we have this limit as h goes to 0, f of x plus h to the n minus x to the n over h equals the limit as h goes to 0, n of 1 times x to the n minus 1. If h goes to 0, this part equal to n of 1 x to the n minus 1. And this is equal to n, so this is equal to n times x to the n minus 1. So there you have it. The proof is completed. Derivative of x to the n using the limit definition is proved. Stay tuned for more rules and examples in the next videos.